This is the voice repeater VK6RLM. It was the first FM 880 repeater that WAG built, and it has quite an interesting and amazing history. It was built in about 1982 from memory, and I'll take the cover off and show you. This is the top side of the repeater. Just on the front, it has a keypad here, which is a DTMF keypad. It allowed you to do some of the DTMF functions that this board here, that's a DTMF decoder. So if you didn't have a handheld, you could use the keypad. That's simply the transmitter switch. In that position it turns the transmitter on continuously, in that position it turns the transmitter off completely, and in that position it's normal, where any signal into the receiver keys up the repeater. It actually has an S meter built in. The FM 880 does not have an S meter, but this one I found a convenient place to put a diode and associated circuitry, and it provides around about 3 microvolts full scale. Has a power switch, a volume switch and a mute switch. These two sockets are standard in the FM 880, but I use them for a variety of functions. This repeater did and connected to many things. At one stage it connected to a HF SSB rig, and it provided a gateway onto 80 and 40 metres and was used for WIA nets that were run, I think, on a Wednesday night. It was all automatic, and you came in on 2 metres and you went out on 2 metres, and you also went out on either 80 or 40 metres SSB. I'm not sure what this one does. A lot of it's going back in memory. A quick run around of the boards. The original FM 880 had lots of boards. They're all stripped out apart from this one, and this is the main regulator board and switching, and that was left in because it was needed, obviously, and fed power to the receiver and the exciter board. At the back you've got the PA. Now, some of these other boards, you'll notice a board missing. That was a CT/CSS decoder, which was needed for the HF linking onto 29 megs. This repeater also, for a period of time, was cross-connected and onto 29.120 FM, and that transceiver sat alongside this repeater, and that was the CT/CSS decoder board that you required a CCTS tone if you wanted to access the 29 meg system coming in on 2 metres. Not all licenses could operate, that could operate on 2 metres could also operate on 29 megs. I'm guessing what this is. It did have a voice ident on 29 megs, and I know that plugged into a voice module which provided voice ident for the 29 megs, and I think that's associated with it. I'd be guessing what that is. There were so many modifications and additions, and the circuits are there, but I just haven't bothered spending the time nutting them all out. As said, that's the DTMF controller, which controlled all sorts of functions in the repeater. It turned linking on and off, it could turn the repeater on and off, do a whole variety of functions. The top board here was for the tone pip. You know, when you let the button go, you get a pip. Well, that was produced there, and it was the timing interface circuitry for that. Coming over to this side, no, I'd be guessing what that does. That's the CT/CSS encoder. It put a 123 Hz on the transmitter carrier at all time. That is the audio AGC amplifier, so that any audio coming in on 2 metres and then rebroadcast through the repeater had some degree of automatic gain control on the audio. And this one is the audio mixer board. There's a surprising number of audios in a repeater. Apart from the normal user audio, you've got your CW ident, you've got your tone pip, you've got the CT/CSS from this board has to be mixed in. Also WIA news linking was linked in there as well. So that's the top of the unit, and if we turn it over, this is the underside, and I've taken the cover off this one, and I'll take the cover off this one as well. The receiver and the exciter is beautifully screened, most important in a repeater, and this one certainly has top quality screening. This is the receiver. Yet another board in here, and I actually don't know what that does. You probably can't see it, but there's another board in there. This is the receiver front end here. They're the two front end tuned circuits, then the RF amp, and then the output tuned circuits. Crystal filter. There's the crystals for the determining which frequency it is on. That's the point where I took an IF output to run the S meter. Discriminator output, etc. So that's the receiver. This is the original controller that was designed by Adrian, VK6RLM. It uses a diode matrix to produce the ident and all the other functions like a carrier tail, timeout, whole range of functions are on that board. I did some modifications to it, but it's primarily Adrian VK6RLM's design. And over here you have the exciter. These transceivers, or this transmitter, the actual oscillator runs at the output frequency, and that's it there. That actually runs in this case at 146.750, and that's a buffer amp, and then the output of that amp goes on that lead to the PA. And the way it's controlled is it has a reference crystal, which in this case is on 18 megahertz, and that goes into it is fed to this comparator, and the output from here at 146.750 is divided down and then compared to this 18 meg crystal and produces a DC output, which then keeps this on frequency. It produces a very clean output. You don't have multiplier chains which tend to produce noise, and hence the noise output from the repeater is higher, which can then get back into the receiver, and you don't want that. You may just be able to see down, there's a whole string of diodes in parallel. This was changed from normal phase mod, which is those two coils there from memory, to frequency modulation, where you actually FM modulate the reference crystal, and it produces a much better audio, better low frequency response, and much lower distortion. So by FMing the crystal reference, of course the VCO will follow, because the different voltage, the comparative voltage, will move that. And it produces a very good audio. Some of this up here is not used. It was due to with like mic amplifier and so forth. But that's the basic design of the FM880. The exciter, sorry, the PA, which I won't bother taking off, is just standard PA. You get about, I think it's about 20 to 50 milliwatts out of here, and then there's 3 stages of transistors that boost it up to the 20 to 25 watts, and the output transistor is actually a 40 watt transistor, and it's throttled back, so it runs very well. So that's the basic FM880, the original old VK6RLM. And when first commissioned, this repeater actually ran with a 3-second timeout, and the idea was conceived on a WAG trip away somewhere, I think to Shark Bay, as a calling channel, so that you could call in looking for someone and they would then reply, and then you'd say, well, QSY to wherever, and it literally had a 3-second timeout. Some amateurs found a way around this. It's amazing the ingenuity of some amateurs. They could actually conduct a QSO of 3 seconds in under 3 seconds, back and forwards, back and forwards, back and forwards. So in the end the idea failed because of that, and it was converted to a normal repeater with a normal timeout. a very long history this repeater has. It was also connected to the Aussat system. For the very first time we heard VK2 amateurs in FM quality excuse me, out on a repeater linked live. As said, it was also linked onto, it also fed and was linked across to the VK6RLM for the WAG net on Sunday mornings. And I'm pretty sure at one stage it was linked down to VK6RMW at Mount William. Very long history. I've not researched it much, I've not given much thought. I thought I'd just make a quick video to show you a repeater that must have had many thousands of contacts through it over, what are we talking now, 37, 38 years, and it may go back into service. So there we have VK6RLM, showing its age a bit, but still a functional repeater. At least I think so. I'll test it out later and see if it works.